Hello friends. Now we are going to start our new problem. In the previous video, we have seen how to calculate moment of inertia of I section. In this video, we have the another section, that is C section. See, sometimes C section is symmetrical about horizontal center line, but here intentionally we are taking this type of problem where the top flange and bottom flange is not symmetrical. As you can see, the dimension of this top flange and dimension of this bottom flange is different. So first of all, see given problem very carefully. The cast iron beam of C section with top flange 150 mm into 15 mm, bottom flange 200 mm into 20 mm, and wave 15 mm into 200 mm is supported over a span of 6 meter. Determine the moment of inertia. Again, here you have to calculate moment of inertia. See, this is your given diagram. This is a bottom flange. This one is a wave, and this one is a top flange. You can see the base distance 200 mm for first flange. The depth is, that is 20. This base is 15. Height is 200. Again, here the base is 150 and the depth is 15 mm. We know that to calculate moment of inertia, the location of centroid point is very, very important. So here you have to calculate centroid point first. So to calculate centroid point, we know all the steps. According to this one is given diagram. You can see this one is the given diagram. So first rectangle, second rectangle, and this one is the third rectangle. So again, you can see this one is the first, this one is the second, and this one is the third. For each and everything, you have to calculate x1, x2, and x3 distances. Here, you have to calculate y1, y2, and y3 also. You have to consider baseline as a x-axis, this line as a y-axis. So accordingly, you have to calculate x1, x2, x3, and y1, y2, y3. See, y1, y2, y3 will be distance from baseline, or you can see the distance from x-axis. And x1, x2, x3 will be the distance from vertical axis. So here, this one is the first rectangle, this one is the second rectangle, and this one is the third. Bottom flange, wave, and this one is the top flange. All the dimensions are given. All the dimensions are given. So here, y1, y2, and y3. Now I'm not wasting the time to explain how to calculate y1, y2, and y3, because already you studied how to calculate y1, y2, y3 in the first year also and in the previous problems also. You know the formula of a rectangle for y1, y2, and y3. So you can calculate y1, y2, and y3 as per the formulas. So here, similarly, you have to consider x1, x2, and x3 for diagram 1, diagram 2, and diagram 3. So first of all, you have to calculate area 1, area 2, and area 3. So for first rectangle, the area is 200 into 20. So we will put the value of base and depth 200 into 20, that is 4000 meter square. Or you can say the dimensions are in mm, then it will be mm square. For the second, again the base is 15, height is 200. So A2 will be 15 into 200, the answer will be 3000 mm square. A3 will be 15 into 150, that is 2250 mm square. So the distances, that is from y-axis, that is x1, x2 and x3, that is 100 mm, 7.5 mm and 75. X1 is equal to 100, x2 is equal to 7.5, x3 is equal to 75. Again, here I am explaining you. This one is the vertical axis. So for first rectangle, the distance from vertical axis, that is x1. Distance from vertical axis, that is x2. And distance from the vertical axis for third rectangle, that is x3. So here distances are x1, x2 and x3. You know how to calculate x1, x2 and x3. Now here, similar distance from centroidal, distance of a centroid from x-axis, it will be y1, y2 and y3. See, in this diagram you can see this one is the y distance, this one will be y2 distance and this one will be y3 distance. You know how to calculate y1, y2 and y3. So the y1 will be 10 mm, y2 will be 120 mm, and y3 will be 220 plus 15 by 2, that is 227.5 mm. So now we have all the areas. We have a distance of centroid from y-axis. We have the distances of a centroid from x-axis for each and every rectangle. So here, to calculate position of neutral axis means to calculate the exact location of centroid point. So here we know the formula: x bar is equal to a1 x1 plus a2 x2 plus a3 x3 upon summation of entire area. That is a1 plus a2 plus a3, that is summation of all the area. So here we know the value of a1, that is 4000. We know the value of a2, that is 3000. We know the value of a3, that is 2250. We have the value of x1, x2 and x3. X1 is 100, x2 is 7.5 and x3 is 70. So whenever you will put all the values in the formula, you will get answer x bar is equal to 63.92 mm. So units are very important. So you have to put unit also. To calculate y bar, a1 y1 plus a2 y2 plus a3 y3 upon summation of entire area. That is a1 plus a2 plus a3 is nothing but total area A. So y bar is equal to a1 into y1 plus a2 into y2 plus a3 into y3 upon summation of entire area. So again, we have the value of a1 y1, a2 y2 and a3 y3. You have to put a1 y1, a2 y2, a3 y3. We have all the values. You have to put all the values in the formula and you have to calculate the answer. The answer is 98.5 mm. Now we have the value of x bar and y bar. So you can see in this diagram, x bar means distance from y-axis. So x bar, we have the value of x bar. You can see this distance, that is x bar, and the distance from bottom line, that is y bar. So here we have the distance of x bar and y bar. Again, the things are same for this problem also. Here ixx is equal to ixx1 plus ixx2 plus ixx3. Here we cannot consider the vertical axis like I section. Here this one is the first rectangle, this one is the second rectangle, and this one is the third rectangle. So you can see that now for first rectangle, centroid point is here. For the second rectangle, centroid point is here. For the third rectangle, center point is here. So here you can see that Ixx is equal to Ixx1 plus Ixx2 plus Ixx3. Here you have to use parallel axis theorem. So for Ixx1, formula will be Ig1 plus A1 H1 square. For Ixx2, the formula will be Ig2 plus A2 H2 square. Plus Ixx3, formula will be Ig3 plus A3 H3 square. Here I am telling you, you have the formula of Ig1, that is BD cubed by 12. For Ig2, again the formula is BD cubed by 12. And for Ig3, formula is BD cubed by 12. But while putting the value of H1, H2, and H3, you have to take proper care. See, you can see here H1, H2, and H3 is the difference between Y bar and Y1. Here the distance between Y bar and Y2. Here the distance between Y bar and Y3. See, you will get the value of H1, H2, and H3. While calculating Ixx, you have to take the difference between Y bar and Y value. So whenever you will put the value according to the given condition, you will get Ixx is equal to 80.39 into 10 raised to 6 mm raised to 4. See, to calculate Iyy, the formula will be Iyy is equal to Iyy1 plus Iyy2 plus Iyy3. See, again here Iyy1 is equal to Ig1 plus A1 H1 square plus Ig2 is equal to A2 H2 square plus Iyy3 is equal to Ig3 plus A3 H3 square. See here, for Iyy, the formula will be dB cubed by 12. So first depth, that is 20, that will be 200. So similarly, see 20 into 200 cubed by 12 plus A1 is equal to 4000, but here H1 distance. See, while calculating Iyy, you have to take H1 as a difference between X bar and X1. While calculating H2, difference between X bar and X2. While calculating H3, difference between X bar and X3. So here just see the value of X bar, that is 63.92. And we know the value 100, 7.5 and 75 as a X1, X2, the value of X1, X2 and X3. So here similar, see H1 is a difference between X bar and X1. H2 is the difference between X bar and X2. Here X bar and X3. Whenever you will put all the values in the given formula, you will get Iyy is equal to 32.64 into 10 raised to 6 mm raised to 4. This problem is very, very important. If you will solve this problem, you will get the entire idea about the moment of inertia. Here, the C section is not symmetrical about any center line. So we have used parallel axis theorem while calculating Ixx, Ixx, and Iyy. Thank you.